Okay, good evening, ladies and gentlemen. It's February 17, 2024, and the time is 9:21 p.m. Okay, my topic for tonight will be a long video format, and this is a random topic. It will be an addition to my long video format discussions. That's why I placed this one on the playlist mixed topics. Okay, the topic for tonight will be the so-called evaluation of complex fraction. Complex fraction is actually very important for those who are planning to take the CET or SAT exam or the board exams maybe. Okay, let's proceed. We are given the problem here. The problem says simplify the given complex fraction. We are given a complex fraction. A complex fraction is by definition on the numerator of that complex fraction, it is a fraction, and the resulting denominator of that complex fraction is still a fraction. That's why it is a complex fraction, meaning a fraction all over a fraction is termed to as a so-called complex fraction. Okay, the given complex fraction is this one. It's a very long one, I will read it. The total value of the numerator is this portion here. And the total portion of the denominator is this portion here. So the dividing line is this one. Okay, I will try to read the complete numerator of the complex fraction. The numerator of the complex fraction involves two fractions. Okay, it could involve one fraction, two fractions, or three fractions. It depends. That's why it is termed to as a complex fraction. The given numerator is the ratio, it's the ratio 3 all over the square of x plus 2x minus 3 minus 1 over the square of x minus 3x minus 10. That's the complete numerator of the given complex fraction. And the complete denominator is the value 3 all over x squared minus 6x plus 5 minus. The operation is minus. This is the first fraction on the denominator, this is the second fraction, and the operation between them is negative. So this is minus 1 over x squared plus 5x plus 6. The problem is just asking, bring out the simplest simplification. Okay, let's try to bring out the solution. The solution will be something like this. I will place it here, the complete value of the numerator. We'll try to expedite a little bit. We are subtracting the first fraction and second fraction and the numerator, right? So if we try to simplify this one, we expedite a little bit. This one here, we will crisscross, right? So we will be using the so-called butterfly method. So this is 3 times the quantity x squared minus 3x minus 10. Okay, the product of this. Minus 1 times this quantity here, so this is minus 1, times x squared plus 2x minus 3. This is 3, right? It's there. And this is 1. All over. We are now combining the two fractions, right? So the resulting denominator will just be simply the product of this first one here and the second one. So it will be the quantity product. I will now place a quantity. X squared plus 2x minus 3 is the first one, times the quantity x squared minus 3x minus 10 close quantity. Okay. The resulting numerator will just be simply an expansion. We will use the so-called distributive law. So 3 times x squared will be 3x squared, 3 times minus 3x will be minus 9x, and 3 times negative 10 will be negative 30. since this is 1, I will change all the signs of all the terms inside immediately. Okay, to simplify, to expedite a little bit. So negative 1 times x squared will be negative x squared. And negative 1 times 2x will be negative 2x. A minus and a plus will be a minus. And a minus 1 times a minus 3 will be plus 3. All over. For the denominator, we'll try to, what do you call this, factorial. The two quadratic equations on the denominator are actually factorable. X squared plus 2x minus 3 can be factored into the quantity x plus 3 times x minus 1. Okay? So, two binomials is the equivalent of this quadratic equation. X plus 3 times x minus 1. The middle term will be 3x minus x, which is 2x. So, the resulting binomial factors of this one will be the product of x plus 3 times x minus 1. And so with the second one. This is factorable into its equivalent binomial factor. And the possible binomial factors of this one will be x plus 2 and x minus 5. Let's try to check the middle term. The middle term will be 2x minus 5x, should be negative 3x. And a plus 2 times a minus 5 will be negative 10. So the resulting equivalent of this one can be written as the product of x plus 2 over x minus 5. Combining similar terms on the numerator, 3x squared minus x squared will be 2x squared, minus 9x minus 2x will be negative 11x, and minus 30 plus 3 will be negative 27. All over the factored form equivalent of the denominator, which contains 4 binomials. The product of x plus 3, x minus 1, x plus 2 times x minus 1. So the simplest equivalent of the numerator is this one. Oh, we are just being systematic, right? Okay, let's try to bring out the denominator. The denominator will be, again, we will combine these two fractions here. So the first portion will be 3 times this quantity here. Okay, it is this. 3 times the x squared plus 5x plus 6. And the second part will be negative 1 times this quantity here. Okay? X squared minus 6x plus 5 all over. The common denominator will be the product of this one. So this will be an x squared minus 6x plus 5, open and close quantity, times open and close quantity of x squared plus 5x plus 5. I put the quantity now because we are now performing the operation multiplication. Combining or expanding the numerator, a 3 times x squared will be 3x squared. Am I still on camera? Okay. And a 3 times 5x will be 15x. And 3 times 8 will be plus 18. Since this is negative 1, I will now distribute this negative 1 inside. So I will now immediately change all the signs of all the terms inside. So negative 1 times x squared will be negative x squared. And a negative 1 times negative 6x will be positive 6x. A negative and a negative is a plus. And a negative 1 times a positive 5 will be a negative 5. All over, again, we will be factoring out the two quadratic equations at the bottom. The quadratic equation x squared minus x plus 5 is actually factorable to the quantity x minus 1 times x minus 5. Okay, let's try to check the middle term. The middle term will be negative x and negative 5x, and that is actually negative 6x. It's correct. So the single equivalent of this, or the binomial factors of this, will be the product x minus 1 times x minus 5. A minus 1 and minus 5 is actually plus 5. Negative x, negative 5x will be negative 6x. It's correct. Again, the second quadratic equation on the denominator is still factorable to two binomial factors. It is the product of x plus 2 times x plus 3. Let's try to check the middle term. The middle term will be 2x plus 3x, and that is actually 5x. It's correct. And a plus 2 times a plus 3 is actually plus 6. So the resulting simplest equivalent of the denominator is this one. Okay, 3x squared minus x squared will be 2x squared. 15x plus 6x will be 21x. And the plus 18 minus 5 is actually plus 13. All over the product of the four binomials, which is x minus 1 times x minus 5 times x plus 2 times x plus 3. Then performing the ratio numerator over denominator. This is the whole numerator. This is the whole denominator. We now know the simplified equivalent, so we will just take the ratio to take the simplification. So the numerator, as per our computation, is this one. This is 2x squared minus 11x minus 27 all over the four binomial factors for the numerator, x plus 3, x minus 1, x plus 2, x minus 5. It corresponds to this. All over. The simplest equivalent of the denominator is actually 2x squared, right, plus 21x plus 13, all over. Again, the product of the four binomial factors, okay? That is x plus 3, x minus 1, x plus 2, and x minus 5. So this is numerator, denominator, numerator, denominator. This is the divisor line. So actually, we could cancel similar terms for both the numerator and denominator. Denominator, denominator. So the operation is multiplication, right? So x plus 3 cancels. They are both denominator. X minus 1 cancels. X plus 2 cancels. X minus 5 cancels. So this is now actually equivalent to 1, and this is 1 also. 1. So the resulting simplified or the simplest equivalent of the given complex fraction will just be simply 2x squared minus 11x minus 27 all over 2x squared plus 21x plus 13. I think this is not anymore factorable to a simplest binomial equivalent. And so with this one, so our simplified solution will be 2x squared minus 11x minus 27 over 2x squared plus 21x plus 13. Okay, that's it, guys. That's how we process or simplify a complex fraction. If it's really complicated, do it by parts. Try to simplify first the numerator, do it separately. Then do the simplification of the denominator separately. And as a final answer or process on the simplification, just take the two ratios, then try to make some cancellations if there are any. We can make cancellations over here because the operation here are all multiplication, in all are multiplication. Like what I said, this x plus 3 cancel with this, x minus 1 cancel with this, x plus 2 cancel with this, x minus 5 cancel with this. So what remains on the denominator on the numerator is 1, and the denominator on the denominator is also 1. So what remains is just the numerator and the numerator. That will be 2x squared minus 11x minus 27 plus 2x squared plus 21x plus 13. Okay, that's it, guys. So for those of you who would like to subscribe to my channel is at youtube.com/@ProfDVJ If you want to share it, click share. Good evening from Los Angeles.